This is the simulation of 9-level switched capacitor based multi-level inverter. This is the proposed inverter. Here we are having two switched capacitor cells. Here C1 and C2, two switched capacitors are there. Okay, here the first part is for level generation, and from S8 it is for polarity generation, that is for inverter operation. Here we will get 9 levels and the input voltage is lesser than that of output voltage magnitude. Why means we are using switched capacitors. So these capacitors will also add in the levels. The capacitor voltages will be added in the levels. So the output voltage will be higher than that of input voltage. Here we are using two sources and two switched capacitors. So when both sources and the number of capacitors are equal, the output will be 2 times of that input voltage. This is the simulation circuit of the 9-level switched capacitor based multi-level inverter. Here this part is for level generation. This part is for level generation, and H bridge inverter is that is for polarity generation. And in this we have this switching table. According to the switching table, we will generate the levels. Here if you see means positive 4 levels: VDC, 2 VDC, 3 VDC, 4 VDC. Negative 4 levels: minus VDC, minus 2 VDC, minus 3 VDC, minus 4 VDC. The capacitor charging state and discharging state also mentioned here. For VDC and 2 VDC, capacitors will be charging, and for 3 VDC and 4 VDC, capacitors will be discharging. Similarly for the negative cycles. So totally we will get 9 levels: positive 4 levels, negative 4 levels, with 0 level we will get 9 levels. According to the switching, we have to generate the pulses. Here in this, the pulses are generated. A sine wave that is converted into unipolar modulation waveform, and that will be compared with the high frequency carrier waveforms. Okay, the levels will be generated for positive cycle and negative cycle, both are of same only. And from that it is given to the inverter. Here these are the inverter pulses, and the output of these pulses will be provided to the respective switches. Here if you see here, this is the pulse waveforms. These are the pulse waveforms. First 6 pulses will be for level generation. Last 2 pulses will be for polarity generation. And before this, here the input we are providing as 9 volt, and for V2 also same thing only. So when these capacitors are charging, this switch and this switch will be on. So the capacitor will be connected in parallel with the source. And when the capacitors are discharging, this switch will be on. So the source will be connected in series with the capacitor. So when the capacitor discharges, the voltage gets added here. Similarly, for the first switch capacitor here, if you see means, when the capacitor is charging, it will go through this diode and go to the next switched capacitor cell. And at the same time, this capacitor will be charging with the help of this switch. So the capacitor voltage will be equal to the input voltage, 9 volt. And when the capacitor is discharging, this switch will be off and this switch will be on. So the capacitor will be connected in series here. The capacitor voltage gets added with the input voltage source. So 9 plus 9, 18. And here also same thing. 9 plus 9, we will get 18. Totally 36 volt we will get as the peak voltage. And these are the load current and load voltage. If you see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the output peak voltage will be in the range of plus 36 to minus 36. Here it is 35. Around 35 we are getting the voltage, load voltage. And to measure the FFT analysis, that is to measure the THT. Here the frequency should be 50. We are getting 14.72%. So these are the results we got from this inverter. You will get 9 levels with the help of 2 sources and 2 capacitors and totally 10 switches. We can further increase the number of levels by increasing the switched capacitor cells. And the pulses will be easier to generate for the higher levels.